when we are looking at matrices, there is no division. Okay, there's no division in matrices, so that means we use what's called the inverse matrix to help with our problem solving. So our inverse matrix is, you'll do these on your calculator, alright, 1, 2, 3, 4. We have to be able to find the determinant, alright, so we're going to call this matrix A, and to be able to have an inverse, the determinant can't equal 0. It can equal 1, it can equal negative 100, but it cannot equal 0. So if we're looking at this, to find the determinant equals AD minus BC. And in our matrix here, we have A, B, C, and D. So, determinant for A here. We have AD, 1 times 4, minus 3 times 2 is 6, equals negative 2. We have a determinant. Therefore, we have an inverse. So, there is an inverse for this. The next thing you'll need to do is make sure that it doesn't equal 0. So if I have, let me work out some nice maths here. My matrix is going to be B, and it can be 2, 6, 3, and 4. AD minus BC is going to be 12 minus 12 equals 0. Therefore, no inverse. Alright. You will be able to do these on your calculator really nicely by doing it to the power of negative 1. Okay? But by hand, they are a little bit tricky and they're a little bit frustrating to do. So, if we were to find your calculator on your CAS, determinant, type in DET and your matrix, and it will give it to you. Alright, that is that. If you are to find your inverse, you need to do it to the power of negative 1. Do your matrix, write your matrix up and do it to the power of negative 1. That turns it into your inverse. If we were to do it by hand, alright, I'm going to get rid of all this. If we were to do an inverse by hand, what have I got? 2, 1, 1, negative 1. 2, 1, 1, negative 1. The first thing I need to do is find my determinant. AD equals AD minus BC. AD, what have I got? Negative 2 minus 1 equals negative 3. My determinant is negative 3. I then take my determinant, and that becomes the bottom number of my fraction to multiply it out. From here, I need to swap some elements, and some elements need to become negative. So, what happens here? Number 1, find det. Number 2, swap elements. So it becomes 1 over your determinant, and then in your brackets, D, negative B, negative C, A. They swap. So, looking here, I need D. D's there. Negative 1 goes there. I now have negative B. It is 1, turns into a negative. Here, negative C turns into negative 1, and that is A. Alright, my position here becomes whatever was there. So from here, you can get your calculator out by now, and you can tell me that the solution for this, negative 1 times a negative a third, positive a third, gentlemen, positive a third, negative, and then we're going to go negative, positive a third again, and 1/3, 2 times negative a third, you've got 1/3, you're timesing it by 2, you now have, or we can do it longhand if you really want, Negative 1/3 times 2 over 1 equals 2 negative thirds. 2 over negative 3. So there is my inverse. Now, the other thing that I need to make clear to you is, let me just make sure that is the actual answer. Yep. So, all good with that. If you multiply a value by its inverse, you will end up with what is called the identity. So a matrix times its inverse equals 1, 1, 0, 0. Okay, and it turns into that. That is your identity matrix. So your inverse is your opportunity to use division. We have the determinant, which you need to find, which is AD minus BC, A, B, C, D. AD minus BC, if it has a value, then basically play on. If it is 0, it does not have a determinant, so it cannot have an inverse. We need to then swap out our elements. So we have a fraction that comes out the front, because 1 over 0, you can't multiply things by 1 over 0, okay, because it's not a value. It's not defined. We have D and A swap, and B and C become negative. So if we're looking here, take your original values from up the front here. Those two values have swapped, and those two values have become negative. We have our negative 1/3 out the front, times all that through, and we have a third, a third, a third, and negative 2 over 3. Alright, and I think that will be about it for that one.